Quantum computing's race to reach practical, world-changing applications just hit another major milestone, and might surprise you where the action is happening. Forget the algorithms for a moment. The spotlight is on the unsung heroes, specialized fridges and amplifiers that keep quantum bits, qubits, reliably cold and stable. Without these, quantum computers simply don't work. But here's where the story gets controversial. Industry insiders are split over which technologies will win out and how fast they can scale. Maybell Quantum, a Colorado-based startup, just made headlines by closing a hefty $40 million Series B funding round. That's on top of the $25 million Series A they bagged earlier this year. What's driving the excitement? Maybell's unique supercooled dilution refrigerators, or cryostats, are designed specifically to maintain the ultra-low temperatures that quantum computers demand. Imagine having to keep the entire system colder than interstellar space just to make those elusive quantum states possible. If you think that sounds futuristic, wait until you hear about the real pressure. The shift from university lab prototypes to full-scale commercial deployments has begun, and Maybell is eager to lead the charge. We're at a crossroads, Maybell CEO Corban Tillemann-Dick explained. Quantum tech is shifting from theory to practical reality, and our new funding helps us create the robust, user-friendly hardware that will enable researchers and companies worldwide to scale up quickly. The company's next move? Rapidly increasing output and delivering products not just in North America, but to Europe, the Middle East, and Asia. Expansion is the name of the game, and that's a bold promise in a notoriously slow-moving sector. But this is the part where most people miss the underlying drama. For decades, cryostat makers focused almost exclusively on academic labs. Now, data centers, the backbone of the internet and cloud computing, are demanding supercooled environments for quantum experiments. Established giants like Oxford Instruments and Bluefors once ruled the market, but there's a tidal wave of new startups trying to disrupt their hold, many with a quantum-specific focus. Will these upstarts reshape the market, or will tradition hold firm? Stepping north to Canada, another fascinating development is unfolding. Qubic Technologies, a spin-off from the Université de Sherbrooke and the University of Waterloo, just secured a CA $925,000 grant from the federal government for a breakthrough project. They're using the funds to develop a new class of signal amplifiers made with quantum materials, aiming to tackle one of quantum computing's trickiest problems: excess heat from electronic amplifiers, which hinders the scaling of quantum systems. Amplifiers traditionally act like mini heating elements inside delicate quantum setups, threatening to disrupt the entire operation. Qubic says their innovation could make those thermal headaches history. Quantum computing is advancing rapidly, but key roadblocks like heat management still stand in the way of utility-scale systems, said Qubic CEO Jérôme Bourassa. The company's amplifier, now in its prototype phase, aims for commercial release in 2026, promising near-zero heat dissipation. Is it too ambitious or a necessary risk? That's up for debate. Qubic claims their federal funding validates demand, not just in Canada, but across the strategic global market. Let's not forget the broader implications. As quantum machines scale up, the need for ultra-low noise, quantum-limited signal readouts grows exponentially. Lynn McNeil from CMC Microsystems points out that superconducting amplifiers are quickly becoming the gold standard, capturing commercial interest worldwide. And now, a question for you. The quantum revolution is clearly more than just faster computers. It hinges on overcoming hands-on engineering challenges like supercooling and thermal management. Should the spotlight and investment stay on these unglamorous but critical hardware solutions? Or is software where the real quantum breakthrough will happen? Tell us what you think. Are fridges and amplifiers the real gatekeepers to quantum progress? Or just expensive accessories in the race to a quantum future? Debate below. Your perspective could shape the community's conversation.